Hello everyone, I'm Sunanta from SNS College of Technology, Department of Mathematics. In this lecture video series, graphical representation which comes under statistical data representation, we are going to see frequency polygon in this lecture video. Let us delve into the video. So here, the learning objectives of this video are: first is to understand the frequency polygon, second is to construct the frequency polygon, third is to interruption skills and the real world applications. So in understanding frequency polygon, we are going to study what is frequency polygon and identify their key characteristics and their visualization part. Next is construction. So how to construct a frequency polygon step by step and proper scaling will be seen. Next, in interpretation skills, we are going to develop proficiency in reading and interpreting frequency polygons to extract meaningful insights about data distribution patterns. Next, in real-world application, we are going to see how we can use this frequency polygon to visualize data in real life in fields like business, healthcare, and social science. So here, let us see the design thinking approach to this frequency polygon. So here is to understanding student challenges with data visualization and statistical representation as the empathy part, and the define parts to identify the need for effective continuous data representation frequency polygon. Next is the idea part in which we are going to explore various approaches to teach frequency polygon construction and interpretation. Next, in prototype, we are going to see how to create hands-on example and interactive demonstration of frequency polygon construction. Next, in test part, we are going to evaluate student understanding through practical exercises and real-world applications. Next is we are going to see what is a frequency polygon. So here frequency polygon is also a one type of graphical representation of a frequency distribution in which we are going to use connected line segments. So it displays the frequency of different class intervals as points connected by straight lines, creating a polygon-like shape. Here the key characteristics of frequency polygon includes plotted points at class midpoints. Next is frequency representation on the y-axis. Next, connected line segment formatting the polygon. Next is useful for showing data trends and patterns. So here this frequency polygon are particularly effective for comparing multiple data sets and identifying distribution shapes, making them essential tool in statistical analysis. Next is the history context. So this frequency polygon was developed as an evolution of histograms. As we have seen already, histograms is also a graphical representation in which we create a bins, and after that we'll plot the data's frequencies in a bar, and we'll connect the lines in the mid value. Similarly, this frequency polygon is one such graphical representation which was as an evolution of histogram. This was developed by Carl Pearson and Francis Galton, which is used to them to analyze biological and social phenomena. Next is in construction process of an frequency polygon. First is to prepare a data, so in which the raw data are organized into frequency distribution table with class intervals as we have seen already in histograms and their corresponding frequencies. The calculation of the midpoint. So find the midpoint of each class interval using the formula upper limit plus lower limit divided by 2. Next, set up axis. Draw his horizontal axis for class midpoints and vertical axis for frequencies. This is plotting of points. Next, mark points where each class midpoint intersects with its corresponding frequency values. Next is connect the points. So next is to connect the midpoints using a straight line. So now let us see one example, which is a construction practice. So here we are using the data set of a student's test scores working past to construct a frequency polygon. So here the intervals are 60 to 69, 70 to 79, 80 to 89, 90 to 99. Here the frequencies of the 60 to 69 are 5, next 12 for 70 to 79, 18 for 80 to 89, and 8 for 90 to 99. Here to calculate the midpoint, we have to add the upper limit plus lower limit divided by 2. Therefore, on adding 60 plus 69 divided by 2, we get 64.5. Similarly, 74.5, 84.5, and 94.5 are the midpoints of the corresponding values. Next, the key advantages of this are visual clarity. So this provides visual clarity using distribution data patterns, making trend immediately apparent to viewers. Next is easy comparison, which this allows multiple data sets to be plotted on the same graph for direct comparison of distribution. Smooth representation. So in this frequency polygon, which creates smooth curves than histograms, better representing continuous data distributions. Next is space efficient. So requires less space than histograms while conveying the same statistical information effectively. So here is the comparison of the frequency polygon with histogram. So in both we are using same patterns. So here in this frequency polygon, we use connected line segments. Next, points plotted at the class midpoints, better for continuous data, easier to overlay multiple data sets, more space efficient, show smoother trends. Whereas in histogram, we use rectangular bars to represent, and these bars span entire class interval. Next, better for discrete data and shows frequency density clearly. This is more intuitive for beginners and emphasizes class boundaries. So both methods are valuable tool in statistical analysis, and choice depends on the needs of the data which is to be represented. Next, types of distribution shapes, as we have seen in the histogram itself, the curves will be normal distribution since they are bell shaped. And in this, it may be both right skewed or left skewed. That is, the data will be crowded in right side or in the left side. That is maximum values. Next is bimodal. The two distinct peaks in the distribution. That is, two different populations are processed at the work. Next is the real world case study. So, healthcare application, so patient wait times, a regional hospital collected patient wait time over a month to improve service quality. The data revealed interesting patterns when visualized using frequency polygons. So first one is data collection. So there are 1,200 patients visiting recorded across different departments and time periods. Next is an analysis. So the frequency polygon revealed bimodal distribution with peaks at 15 minutes and 45 minutes. Next is insights. The two distinct patient types, routine appointments and emergency cases requiring different service approaches. Next is action, so which is implemented separate queuing system reducing average wait time by 30%. Third is the mind map. So the first one is the construction part. Next is the related comparison tools, distributed types, applications, and advantages are the things which we have seen in this topic. Next is assessment method which we use to assess the students. This is a test part. Next, the key takeaways of this frequency polygon are definition mastery. So the frequency polygons are line graphs connecting points at class midpoints, creating frequency polygon that represent data distribution. Next is in construction skill. So follow the five-step process: prepare data, calculate midpoint, set up axis, plot points, and connect with lines. So here are the practical value. This is excellent for comparing multiple data sets. Next, representing continuous data distribution, whereas in histogram we use discrete data types, and the real world impacts where we can use this histograms. So here are the references of